Okay, so we can get started. So again, hello everyone. My name is Adam Dziedzic,
And I'm Franziska Böhnisch.
and today we have a pleasure to inform you more about our European Championship in Warsaw that is taking place this coming weekend on May 9th and May 10th. And this is actually our Polish edition of this championship. First of all, a bit about us, so who we are, who are the people behind this championship. So, how I describe myself is that I am a researcher who travels the world to work on the forefront of AI research. So, in my case, I did my PhD in the US at the University of Chicago. I also work at Google and Microsoft and an investment bank in London and many more institutions. Similarly, Francisca.
I also do research on artificial intelligence, and I obtained my PhD in Berlin and have conducted research days all around the world, for example, in Taiwan and the Netherlands. And I did my postdoc in Toronto at the Vector Institute for Deep Learning and AI as well.
There is another question if the recording will be shared afterwards. Yes, we'll share actually this via YouTube, and we also share the link on Discord.
All right. And also to talk more about the institution where we currently work, CISPA is a research center in Western Germany. And we work on very exciting topics at the edge of machine learning and security. And our location is somewhere between Frankfurt and Paris. And we are a very international community here with roughly 700 employees from 66 different nations. And we have currently more than 40 faculty who do research on different topics. And what we're extremely proud of at CISPA is that we do not only do research, but we do research extremely well. Namely, if you look into CS ranking, which is the standard ranking for computer science, and you look for the categories on cybersecurity, then you will find that CISPA is the number one in the world. So our research here is like better ranked than any of the elite universities. And yeah, therefore we are extremely proud. And at this institute, Adam and I, we co-lead a lab, which is called the SprintML-Lab, which works on different topics on secure, private, robust, interpretable, and trustworthy machine learning. That's why we call us the SprintML-Lab. And we have roughly 20 members, counting our PhD students, postdocs, our research interns, and students who work with us for their thesis. We're also pretty international, and you're going to meet many of our students during the hackathon, as they will be there to assist you while solving the tasks.
So now let us tell you more about the event in Warsaw. Actually, this is the sixth edition of this championship. It's our so-called local hub. So we already went to five other different locations. So, for example, we went to Paris, Vienna, Stockholm, Munich, Barcelona, and now is time for Warsaw. And actually, this is the sixth regional round of this championship and the last one before the grand finale, which will be at CISPA in July next year. So, also regarding this final goal. So, what are the awards for this championship? So, the top three teams advance to the grand finale at CISPA in July, and we sponsor for these top three teams from each location, including Warsaw, to travel to this grand finale. And then for the teams at the grand finale, we'll also have additional prizes. So the first place will receive 4,000 euros, second place 2,000 euros, third place 1,200 euros, and runner-ups, all the teams actually will receive 400 euros.
So if you manage to be at the top three teams in Warsaw, then you already won, basically.
And then you can also compete further in the
Exactly.
final at CISPA in July. So, what about this specific 24-hour hackathon championship in Warsaw? This is the plan for our event. So, we start on Saturday, this Saturday, May 9th, and we have registration for you at starting at 11 a.m. So, please come. You can also get to know us more. We'll also provide you some snacks, drinks, so that you will never get hungry. And then at 12, we'll start our opening plenary session with information about the tasks that you will be working on during the hackathon. You can already reveal that there are 3 tasks during the hackathon. And then at 12:30, after we announce these tasks and tell you more about the competition, the hackathon, the whole event really begins. So you can then start thinking about how to solve the tasks. You can start planning how to code. And then once you do all of that, at 5 p.m., we will have dinner delivered for you. And then further, we can stay for the whole night at the location to code, to hack, and to work on these tasks. So this will be the whole night endeavor. And then after the whole night at 8 a.m. in the morning, there will be also breakfast delivered. And we will further work on these tasks until 12:30 when the hackathon ends and we'll have lunch delivered. Then at 1:30 p.m. we'll ask for the presentations from the best 6 teams from the hackathon. And then those teams will present the solutions to the tasks, how they will show to all of us how they solved the tasks. And then how it really works is that every team will have 6 minutes to present per each task 2 minute short presentation how they solved the tasks.
Yeah.
After the presentations that are given by you at 2:30 p.m., the jury, the technical staff, the CISPA experts will all meet to determine the winners of the hackathon. And then at 3 p.m., we'll announce the results, and we have also the award ceremony for all of you to basically receive the awards, and then the 3 best teams will also advance to the grand finale at CISPA in July. And if you haven't done so yet, then please join our Discord server. So over there, we'll have all the information for you regarding also the initial information about the tasks, like the materials that are actually for you recommended to read through before the hackathon. Also, we'll have information during the hackathon regarding the tasks themselves, regarding the access to GPUs and other information. So this is our kind of hub for communication before and during the event. So if you haven't done so, please join our Discord channel, which is here. The link is at the bottom of this slide. Okay. So now it's interesting for you how we'll really work with you during the hackathon. So we have this scoreboard that actually shows for each team how well they perform. So we have per tasks, we have here 3 tasks. We show what is your score per a given task per team. So you can find out how you perform compared to the other teams at this hackathon in Warsaw. So you can see per task 1, 2, 3, where are you placed in this position on the scoreboard. And also we have the overall ranking that aggregates the scores across the 3 tasks. And then you can see where the team overall in the whole ranking from the 3 tasks performs. So this is the overall information about the hackathon. And then if you have any questions, please either you can also unmute yourself and potentially switch on your camera, or you can also ask the question in the chat and we'll moderate the discussion. So are there any questions regarding this first part, the overview of the hackathon? I think that we don't have any questions yet. Okay, great. So we can move on to the next part. So now we'll start the technical part. So this is information for you to better prepare for the event. So here we'll give you the background about the AI and security and the work that we do at CISPA about our research. And this is really great starting point for you to think more about these topics and also then potentially read the papers that we also present here or that we actually send to you on Discord. And this really helps a lot to prepare for the event. Okay. So current leading generative models such as GPT, Gemini, Claude, and Llama, they are trained on large amount of data which is very diverse. And actually this data used for training of these models, they include news articles, pieces of music, books, code, images, and much more. This scale and diversity make modern generative AI so powerful. They enable these models to generate high quality content from complex text to photorealistic images. But these capabilities also create profound risks. First, our research showed that generative models memorize their training data and then regenerate thousands of training samples verbatim. The models are also able to memorize entire books, images, or songs. This problem led to more than 60 lawsuits on the illegitimate use of copyrighted data for training, which also resulted in claims of over 90 billion euros. Second, generated content is exploited to produce misinformation and fake news at scale, which undermines our democratic processes. Finally, generative AI creates data loops. Content produced by the models is shared online, then scraped and reused to train the next generation of models. In the long run, these data loops degrade the quality of models. Specifically, they amplify harmful biases from earlier model versions and carry them to new models. All of these risks point to the same scientific challenge: data provenance for generative AI. We need to know where data comes from and how it is used. Our solution is to build a data provenance framework for generative AI. The overarching goal is to identify what data was used to train generative models, such as books or videos, then to distinguish between human-created and AI-generated content and trace where the generated data is used. Our ambition is to provide strong statistical guarantees so that the data provenance becomes not only possible, but scientifically rigorous and enforceable. And this is highly timely, since the EU AI Act comes into effect on August 2nd, 2028, and this requires transparency for generative AI. Our goal is to provide exactly this missing scientific foundation. Achieving these goals requires addressing three fundamental scientific questions. In the first part, we focus on the inputs to generative models. Here, the question is, how can we identify and prove whether a given dataset was used to train a generative model? In the second part, during model training, the question is, how can we formally define and quantify memorization? Here, the goal is to control the memorization during training. The model should not memorize individual samples, like whole books or images, but the models should learn general patterns. And the question in the third part on the output side is, how can we persistently mark generated data to identify the data and prevent its use in the training of the new models? Let us start with the first part, data identification. In our research, we showed that identifying if a single data point, like a sentence or an image, was in the model's training set is impossible. This is because big generative models are trained on large amount of data, and the signal from a single data point is too weak. But also in the real world, a writer does not want to detect if a single sentence from their book was used to train a model, but rather the writer would like to find out if his or her whole book was in the model's training set. Our research showed that we can detect if a dataset, such as a whole book or video, was in the model's training set, since in this case, the signal is strong enough. So how does the method work? The LLM data inference method consists of 4 stages. Let me walk you through this one by one. So here, a victim approaches an LLM provider who owns this suspect LLM. The victim's data consists of the suspect and held out sets. The held out set is guaranteed as not used to train the suspect model. For example, it can be draft of articles. For example, if an author wrote a book, probably the author has some drafts of this book, so actually these drafts can serve as the held out set. And also it's important that the held out set comes from the same distribution as the suspect set. And both sets are also divided into non-overlapping splits, partitions A and B. Then a victim, for example, author of a book, claims that the suspect set of this data points from split A and B, so this suspect set was used to train the given LLM. In the second stage of this process, we extract membership features. So the A splits from the suspect and held out sets are passed through the LLM to obtain their features. And these are the scores generated from various membership inference methods for LLMs. So these features can be, for example, in the simple terms, something like the loss from the model on a given input. In the third stage, we learn correlations between features and their membership status. So we train a scoring model using the extracted features and assign label 0 to suspect features and label 1 to the held out features. The goal is to identify useful membership features for a given model and dataset. In the last fourth stage, we perform the final dataset inference. We use the B-split of the suspect and held out sets, perform these membership inference attacks on them for the suspect LLM to obtain the features. Then the obtained features are aggregated into these confidence scores using the previously trained scoring model. And actually then we apply statistical test on these obtained scores. For the suspect data points that are members, their confidence scores are significantly closer to 0 than for the non-member data points for which the expected scores should be closer to 1. And then finally, we take into account the B-splits from the held out and suspect sets. So we take these features and then we perform all the previous stages to arrive at the final decision. So here we run a statistical test on the scores from the suspect and held out sets. And then what is the intuition here is that if the scores are much different from the suspect and held out sets, then actually we decide that with high probability, this suspect set was used to train the given LLM. We call this dataset a member. And then otherwise, if these scores are similar, so the scores for the suspect features and the held out features are roughly the same, then we have the decision that probably, with high probability, this given suspect set was not used to train a given model. Now, what we really want is something more. So our research goes far beyond this initial result. Generative models not only use data sets for training, but they also generate new data sets like articles or videos. And really our goal in our research is to unify the identification of both training data sets and generated data sets. So in both cases, we need to identify specific features that form a signature of these data sets. And our new dataset inference method aims at providing statistically significant provenance guarantees. So, are there any questions regarding this first part about how to identify what datasets were used to train a given model? Seems to be that nobody has any question. Okay, if not, then we can move on to the second part of the info session, which is about data memorization.
As Adam already mentioned at the beginning, Generative models these days achieve impressive performance in generating images and text and videos. Here you can see some images that are generated with the state-of-the-art image generators. The problem is now, though, that the models to generate such data, they need to be trained on horrendous amounts of data from each and every one of us. And this data then is in the models in some way or the other, and especially some data points can be memorized by the models. Adam already mentioned it, but I just want to give some more concrete examples. We've probably all seen recently that there is so much going on in the news about what it actually means when those models memorize and then generate some copyrighted content. And there are dozens of lawsuits between artists and media houses against these model providers. So what it really means for a model to memorize is that we give it some training image. For example, here this image of the cat and the prompt an image of a cat in the office. And it has been actually shown by researchers that if we now give a similar prompt, for example, a cat in the office, then if the model memorizes the data point, it might be able to verbatim generate this data point. And this, of course, can be not only a risk for privacy of the individual whose data is concerned, but also for copyright. Now, in this setup, it's relatively simple, I would still argue. Namely, you have a data set and you train the model on it. It's like one, it's a simple go, and we kind of understand this input-output relationship better. But it gets more fundamental because the foundation models that we operate with these days, they are not only trained on a single data set in one go, but they are instead trained on a whole pipeline. So just to give you some overview on large multi-model models, they undergo a very complex training procedure where we start with an LLM that is just pre-trained on text, so it's a pure language model. But then we further add some text instructions. We fine-tune the model more on vision pre-training, on speech pre-training, and then have some additional multi-model adaptation. And after all of these steps, the model will be a large multi-model model. And now, as you can imagine, the text that we need for the images or the speech that we need for all of these stages can be very diverse. For example, we can insert some stories, some dialogues, images, audios, and some Q&A into the different stages for the model to perform well on their tasks. But the problem is now that not only in a single dataset, but in each and every stage here, we can introduce personal identifiable information. There can be names or email addresses in the text stories. There can be some private information in the dialogues. We can have some personal identifiers inside images, and the text that people speak or the audio can have some sensitive information spoken by the individual. And now the problem is that if some of this information got into the model, and even if we query the model after all these stages and ask it, for example, to complete the sentence, my phone number is, then it might output the same sensitive information. And this then, of course, becomes a privacy risk. So now there is some more theory on how we can define what is really memorized. And the simplest theory here comes from this paper on extracting training data from large language models. And there, the mention is that we have some form of prefix that can be here the first part of the sentence. For example, my phone number is, and then a suffix. And we then give the prefix to the LLM. And if it's able to complete the suffix correctly, then we say the data is memorized. Here in our case, if we ask the model to complete the sentence, my phone number is, and it correctly gives us the right phone number, then it must have memorized that, and outputting the phone number will be a privacy breach. Now, with this definition, there is still some caveats because if we choose the prefix too small, then the model won't be able to continue, so we won't be able to really measure the memorization. And if the prefix is too large, then it's kind of trivial because everything has narrowed down already so much. We nearly already forced the model to output this information. It's kind of like copying. So ultimately, and this is what you also, I think, can research already before the hackathon, is really how to get the model to output its memorized information and what to really input and then how to measure that.
Okay. Are there any questions regarding the memorization part? Okay. So if there are no more questions, so then we can move on to the third part of this talk, which is about outputs from generative models. And here our focus is on how can we really identify what data was produced by the generative models. So here um, one of the flagship solutions is watermarking. So we watermark the outputs from the models, then to be able to find out that a given text is or image is generated. So let me tell you more about how can we watermark the outputs. And here in this case, we'll focus on large language models. So first, a very, very short primer on how LLMs generate text. So actually they generate text in the so-called autoregressive manner, which is like this. So we give to the LLM the first word, which is this, and then the LLM generates the next word, which is is. And actually we append this word is, the second token to the first token, and then we have this whole prefix to the LLM given this is. And then the LLM internally actually has a vocabulary. This is a large number of possible tokens that the LLM can generate given the prefix. So here for each token in the vocabulary, we have assigned probability. So LLM, before outputting the next token, has this assignment of probabilities to all the tokens in the vocabulary. And in this case, since token fine has the highest probability, actually the model would, in this case, if it's greedy decoding, would just return the word fine. So overall, in this greeting prediction, the LLM would predict the token, which also has the highest probability. Now, how can we really watermark these outputs from the large language models? So it is internally done in so-called red-green manner. So we divide the vocabulary into the red and the green list of tokens. And usually we do that actually at random. So for the next token that we want to predict, before we generate the token, we first divide this vocabulary randomly into the roughly equal number of red and green tokens. So if the text is clear, meaning non-watermarked, then actually we should, in the output of the given algorithm for watermark detection, get that in this text there are roughly the same number of green and red tokens. However, if the text is watermarked, then actually we would expect in this text that there are more green tokens than the red tokens. Now, these are actually examples of the text, which is actually color coded. So we here, for the red, we just code that these actually are the tokens from the red list, and in green, the tokens from the green list. So if the text is no watermark, so no watermark added to the text during generation, which is the top part of this image, we see that there is roughly same number of these green and red tokens. However, if the text is watermarked in the bottom part, so with watermark, we observe that most of these tokens in this text are actually green tokens. And there can be also a few red tokens. So this is also happening because we don't want to force LLM to always generate only the green tokens, because we want to preserve the quality of the text. Now, you can also see here that I'm going back to this example with different probabilities. So in this case, the token fine would be in the red list, token great in the green list, and token nice in the red list. So normally if we would just do greedy decoding, we would output the token fine. However, here because the token fine is in the red list, we wouldn't like to output this token, but we would like to instead output the token great. So in this case, we would output the token great. Now, let me give you a more deep dive into how do we really generate these watermark tokens. So here is the algorithm from this famous paper about red-green watermarking for large language models. So we're given as input to this algorithm some prompt, so initial text, and then these tokens that are given as a prefix for the model. We have then a for loop, so we then in the for loop generate the next tokens one by one. So this is basically this next token prediction. So now in a first step, we we give to them, to the LLM, these tokens, the prefix, the input, and then the model outputs the probability vector over the vocabulary. So for each token that the model can predict, we have the probability. So as we saw in the previous example. Now, for the second step, what's happening is that we compute a hash of the previous token. Can be also the window can be varied, so it can be the very last token, can be a few more tokens, and then use this as a seed for a random number generator. And we need that to actually split this vocabulary into these two lists, so the red and the green lists. Now, once we have these red and green lists, then actually we sample the next tokens. And here in this case, we have hard rule that we only sample from the list G, which is the green token list. But in a standard way, here how we do that is we slightly nudge the LLM to prefer to give higher probabilities to the tokens from the green list than from the red list. So now, once we output this watermark text, the next question is how can we detect if a given text is watermarked or not? So to do that, we perform statistical testing, and here we test if number of the green tokens in this text is significantly higher than the number of the red tokens. So if the text is indeed watermarked, then we will observe, as in the previous examples, most of these tokens being green. The text is non-watermark, so there is no sign of any watermarking. The text is clean, and we have roughly from this algorithm same number of green and red tokens. Okay, so actually this concludes our technical part, the information about the background that is also useful for you for the event itself. So are there any questions regarding data identification, data memorization, or data watermarking? Okay, apparently there are no questions. Everything is crystal clear. Okay, so we can, I think, move on to the next part. Okay, the next part is about compute infrastructure. So here during the event, you will also use GPUs. So if you really want to solve these tasks, then you have to basically use this GPU hardware to be able to, for example, train some models or do some inference on large models. So the Jülich Research Center in Germany provides us with this powerful compute infrastructure. So we have at our disposal many GPUs. So during the event for the main jobs, we expect that all of you should be able to access 800 GPUs. So how to get started with this GPU infrastructure? You have to first register at Jülich. So I also sent quite many times already a few links. So please follow these links and then register for our event with this Jülich cluster. And then you also have to accept multi-factor authentication. So for that, I usually use Google Authenticator, but you can use any tool that you prefer. So this is just to enable this multi-factor authentication. Then just sign the user agreement. This is just to make sure that during the hackathon you work on these tasks. So use GPUs to solve the tasks from our hackathon. And then also you have to manage your SSH keys. So if you have one already and you want to use it, then you can just simply cut. So meaning that you can just find your SSH key, show it, and then just copy that over there, the public one. If you don't have SSH key or you want to use a new one, just generate a new SSH key. And then these are just standard things to do at Jülich cluster. So also it gives you IP addresses from which you will be accessing these GPUs. So here I just tell you just copy these IP addresses from the window that actually shows all of them to these additional public key options. So here is important point is that if you are now working on a VPN, then please do that by all means. Potentially, if you come to the venue on the day of the hackathon, then you might redo that to just make sure that you have the IP addresses from where you query this Jülich center. Okay, so Some of you already applied, and then I gave them access to this cluster. So if you apply, you have to be a bit patient. So it takes up to 15 minutes to update our servers and also for me to click on that. But once it is done, that you should be able to access the GPUs. So how to connect to the Julish login node? So this is the starting point. So you just SSH, you can specify which SSH key you use, and then you just type your login and the specific address for Julish. Now, how to do development during the event? So here, what we usually recommend is to use Visual Studio Code, but feel free to use any tool that you prefer. Here, most of our participants, most of our students also as well, they usually use VS Studio Code. So we here just give a couple of slides to show you how you can leverage this tool during our event. So first thing first, configure SSH hosts. So here you have to just add a new um, SSH host, which is Juli's login node. So you just select this SSH configuration file. It can be, for example, .ssh config. In this config, you have to just copy paste these values. So here you just specified host as being Julish, the host name, username changed to your username, identify is your SSH key, public key path. Oh, sorry, it's a private key actually path. And also you have to, if you are Windows user, and also use this Mac S. So this is actually something that will enable you effortlessly to connect from Windows machines to this ULI center. Okay, once you added this node for ULIS, you just then select which node you want to connect to. In this case, you want to connect to this ULIS node, and then you are there. So you are now connected to ULIS Center. You can start a new terminal. Then in the terminal, you have to also activate the project. So usually there are commands such as jutil and activate -p training. And in our case, actually, it is 2615. So this actually has to be updated. And you also have some commands how to access your project for the whole hackathon. You can also access your and create and access your specific folders and files. And then for managing all the Python packages, we actually recommend using UV. So actually this is a tool which is blazingly fast, can download the packages and easily, seamlessly install all of that, and you can in no time run any project. So please, if I can recommend something, then please use UV. And then if you also want to configure that fully to use effectively during the hackathon, copy paste these 3 lines to your .bashrc file. And then there's additional commands for the terminal, so you can just initialize the project, so uv init -p, you specify then the Python version. You can add specific packages and also activate the environment using just standard source. Okay, and then what's also important is that during the hackathon you have to create a submission script, which is a bash script. And actually this is a script that enables you to really execute the batch job on a cluster. So here you can, as a first step, you can copy paste this script. You have to just change training to be training 2615 for us for the Warsaw. You also have specific partition for this hackathon, which is DC GPU. This actually will ensure that you can use the 800 GPUs. And then you also have to just specify your environment and then execute the Python file that is the source of the solution for the given task. Now you have to submit the script, so you just use sbatch main.sh. That this will enable you to submit the batch job to the cluster with this many 800 GPUs. And then you are really ready to use the GPUs. So you have access per node to like 400 GPUs. So for sure during hackathon, there will be no problem for you to have enough resources to work on these tasks. Okay, so this was about compute and the whole infrastructure. So we covered the general information about the hackathon. We covered the knowledge that it's recommended for you to acquire before the event, and also the GPUs that you will be using during the event. So are there any questions about any of these parts? You can either also write the question in the chat if you want. If you want, you can also unmute yourself and just ask the question, and we are here to help you and hope that you can also enjoy the whole event. So we'll wait a few minutes. Mm. Okay, so there is a question. Could you please clarify the policy on AI coding assistance during the hackathon? Are tools like GitHub, Copilot, ChatGPT, Cursor, Claude Code, or similar LLM-based coding tools allowed for generating code, debugging, documentation, or architecture suggestions? If they are allowed, should the teams disclose their use in the final submission or presentation? Thank you for this question. I think it's very important. So actually what we think is that we see this great development of large language models, of generative models in general. And I think that overall, this is a progress. So from our perspective, what we would like you to understand is this research behind the task. So we really would like you to focus on this knowledge. So we really want you to learn about these topics. This is our main goal. If using these tools like Claude, OpenAI API, Codex, or anything like that helps you, by all means, please use them. Also, we would really appreciate if you would also tell us more how you were able to efficiently or effectively use these tools to solve the tasks. This is something that also we appreciate. And nowadays, also even in research, people search for new problems or even solutions using these tools. So by all means, you can use these tools, but also we would like to ensure that you understand these topics that you are working on. So one thing is to use the tool, other thing is to understand how the tool really generates these answers, or if these answers are correct, or if they are giving you really something that is of value to solve the given task.
And how this will reflect in the final rating is that we have this presentation, and it happened that people presented their solutions. The solutions achieved a good score, but then the team was not aware of what they were doing. And of course, then they have been ranked down for the final solution. So they eventually did not make it to the top 3 teams. So ultimately, it's really important, as Adam said, to understand and to be able to transmit how the solution was achieved.
Okay, great.
The next question is on how the submissions work. And how that usually works is that we present you with some code for example submissions. We have programmed an API, and each team gets some token, and this token allows you to access our API. Usually within this API, the submissions, depending on the tasks, are just simple files. They can be, for example, a CSV file. If your task was, for example, to classify images between like class 1 and class 2, then the CSV file could be formatted that the first column would be the name of the file, and the second column would be like 1 or 2, and then our API would evaluate that. In terms of how many submissions are allowed, we usually have some cooldown between submissions. So when you basically submit a solution, then you cannot immediately submit another one. But usually there is a 5-minute cooldown time. This is just to avoid that people kind of reward hack this scoreboard. And it's also to avoid that basically people run some form of DDoS attacks against the scoreboard such that it becomes unavailable for everyone. So you have this 5 minutes cooldown. However, there's a difference if you have a failed submission. For example, if your file is malformatted or something like that, so it was just an error and you have not been evaluated, then usually the cooldown is shorter and can be down to only 2 minutes, for example.
So does this answer clarify the question regarding the submissions during the hackathon? Okay, I think that probably yes. If not, please speak up, or you can send us another message to the chat. There was another question. So a person has just wrote that they just submitted a request today to join a project using training 2615 as the project ID on Ulis. How long could it take until the person can be granted access? So how it works is that once you submit this request, then actually I get a notification that I should accept you. So it might take me, usually I try to do it very fast. So once you submit that within depending if I'm on my laptop, a few minutes I'm there and I accept you. If not, you might wait a bit longer, up to a few hours, but it is usually very fast. And then once I accept your request, then actually you have to wait usually less than 15 minutes just to make sure that our servers are updated. So it should not be too long before you will be able to access this Julish infrastructure. So I think that what we described in one of the slides. So yeah, once you log in, okay, once you register, yeah, I think that this was. Yes, here. So usually, okay, once I accept your request, you have to wait up to 15 minutes to get access to these GPUs and then access the login nodes. Okay, I hope that this clarifies the question regarding the Ulysses infrastructure. Okay, great. Thank you for the confirmation. And then there is another question. For the dataset, is there any rule on dataset? For example, using data from the outside. So there are no rules. So if you want to use any dataset that we haven't provided, by all means you can use them. So here it's up to you. If a given dataset would help you to solve the task, if by any chance it was something that enables you to, let's say, solve the task faster, by all means you should do that. And of course, like we also actually provide links to some data sets, usually via Hugging Face. Also, actually, we upload our data sets to Ulis, so you can download that from either sources. And if you have your own data set or you want to use any other data, it's up to you to do that. So no problem with that.
The next question is a question on the link not working. And we did have this in the past. Usually what fixed this problem was to just use a different browser. For example, use Chrome and then try a different email address. And this has in the past always solved the problem.
Maybe so what is worth mentioning is that usually Ulis recommends using the university or institution email addresses. So, for example, many of people who already got access, they use addresses from Warsaw University or Warsaw University of Technology, also from other universities in Poland. So please use your university address, and then usually there is no problem. In my case, I use Firefox. There are no issues. If people use Chrome, no problem. Um, I think that if you have any issues, then please potentially contact us on Discord, or even send to me direct message, and we can try to debug that. But there were usually not many issues with that.
Also, Jülich has the direct help, basically,
Oh
where
yes,
you can just drop a
I think
message
might be the
to
best.
get registered.
Yes, maybe the best approach to just contact directly Yuli's support and then explain to them that you are joining this project training 2615 for the hackathon in Warsaw, and I think that they will be also more than happy to assist you with this problem. Okay. Thank you for all the questions. Okay, I think that
Looks like we do not have further questions, but all the questions can still be asked on Discord until the event itself. And one thing that is also worth noting probably is that if you do not have a team yet, Discord can also be your perfect place to find some teammates, because usually what we recommend to people is to participate in teams of 3 or 4 people, just to have enough work power to really solve all the tasks. So if you're a team of 2 people, or if you do not have a team at all, then just use Discord to find some teammates, and then you can eventually just register as a full team. And one other thing is that also teams are not allowed to collaborate, so every team should have their individual solutions for the hackathon.
there is one more question. What is provided at the start, data, model checkpoints? Yes, so during the hackathon also we announce the 3 tasks. We provide the description of the task, so there's a PDF for each task with very detailed explanation how to solve the task. If the task also requires you to access some model, for example, some LLM, we also give either links to the checkpoints, but also usually actually we even put the whole model, if it's open source model, either on Juli's infrastructure, so you can also directly even copy paste to your folder, or we can also we also provide a link to our Hugging Face, where we also store our data and model. So there is no issue with access to data or models during the hackathon. Everything is provided in at least two, sometimes even three places. So if one would fail, let's say Hugging Face, you can always copy paste this model, checkpoint, or data from Julish. So usually there is no problem with that.
The next question is on the rooms, and here it will be like that we have several nice co-working spaces. So multiple teams will share one room together, and on the day itself, you will learn basically what is your team number after the registration, and then every team gets one of these tables assigned. So you will have all of this information on the day itself.
Mhm. So regarding organizations, also we have a big classroom, like an aula, where we also announce the tasks. So this is a standard big room for like 200 people. So after the announcement of tasks, also presentations, then you will also be assigned to these specific desks. So there are, as Franziska mentioned, just co-working rooms. So these are actually bigger rooms where a handful of teams, a couple of teams can also share this space together. Okay, I think that we have good timing. There is
Yeah.
5 minutes left, so we can still like wait here if there are any questions. If you still have some questions, please share with us. And if not, then we will slowly finish as planned by 6 p.m.
And I'm also happy to see that the problem with the link that's not working seems to be resolved. I just accepted the request from the person who said they couldn't join, so great that this worked immediately out.
There is always some delay, so if you apply with your university or institution or company email address, usually it's easier for us to verify and then we can immediately accept you. There's also another question. How how do you fetch the project ID, or does someone from our team has to create it? So project ID, I'm not sure what is meant here, but I suppose maybe team ID. So team ID will be assigned to you during the hackathon. So you cannot really fetch it as of now. This will be distributed at the event itself. So usually we send the email to the lead of the given team. So it's also good if you indicate who is the lead of the team, and then these team IDs actually are sent to the teams to the email addresses of the team leads, and then project ID. So actually, the tasks they have their IDs, but all of that you will learn during the hackathon at the very beginning when we announce the tasks. We also share the documents that describe step by step what is expected, what is the task. So I think at this point you don't have to fetch any IDs. If it's about project ID for Julish, so actually the project ID is training um, 2615.
That's the same for everyone, and this is just basically given.
Yes. Okay, let us. There are a few more questions. So, will a recording of today's meeting be uploaded somewhere? I joined a bit late and would like to catch up. Yes, so we already mentioned, but let me repeat. So, this session actually is recorded, and after the session, we'll also upload this recording to YouTube, and then we'll share the link to YouTube on Discord.
Also, the slides PDF will be shared on Discord.
Yes, also the slides so that you can copy paste the comments, for example, and then it's easy for you to start working or preparing for the hackathon. So this is great that you already want to do it now. I think this is really worth doing that now, so that once you come to the hackathon on Saturday, you will just hit the ground running and you'll be ready to just fully focus on how to solve the tasks. So also we recommend you that also we send these links to the papers that we recommend reading. So these are papers that also cover in more detail all the topics that we discussed today. So please, if you still have a few days and you would like to learn more about these topics, then please check out these papers. I think they're a really great source of learning more about AI, how to make AI safer, more secure, more trustworthy. Mhm. Okay.
I think we reached time, and it looks like we also reached the end of questions. So thanks everyone for having been here, and looking much forward to seeing you on the weekend.
Okay, thank you and see you on Saturday.
Bye.
Bye.
Bye, thank you.
Thank you.